How do we define a function based on how it appears in a graph? Let's look at number 7 here. Identify each of the following functions as a power function, an algebraic function, a trigonometric function, or an exponential/logarithmic function. Okay? Each one of these classifications has a very basic definition. Okay? Starting with the power function here. Okay? The basic definition for a power function is essentially this. It has at its heart a constant times our input value to an integer power, more specifically a positive integer power. And those are very easy to define. They have very clear identifiable end behaviors, positive infinity, negative infinity, as well as no asymptotes. Okay? An algebraic function is basically any that uses our basic operations. So it has a combination of addition, subtraction, multiplication, division, and that also includes our rational powers, so basically any exponent where n is a positive or negative integer, or can be written as a fraction, and that includes roots, whether it's the square root, cube root, anything like that. Anything that falls underneath the heading of these 6 basic operations can be considered an algebraic function. Trig functions, those are periodic, they increase and decrease periodically, and they follow a certain pattern. And then exponential or logarithmic is something that looks like this. It's either a times some other number to the x power, or if in the case of a logarithmic, it could be log of some number x, like this, or even natural log of x. These two are related just like power functions and root functions are related. Okay, so looking at the first graph right here, number 1. Once again, there's no identifiable asymptote and there's no break, and it has identifiable end behaviors here. Therefore, this is a power function. Okay, so looking at number 2. Once again, we can identify its end behaviors. So we have negative infinity to the left, positive infinity to the right, and there's no asymptotes here. So therefore, this is another power function. Looking at the third graph, going across to the right here, once again, take a look here. This has no identifiable end behavior to the left, and it also has technically an asymptote here. Okay, so then that would make this an exponential function. Looking at the fourth one right below here. Okay, now we saw problems like this. We saw functions and graphs like this before, where we have one horizontal asymptote and then one vertical asymptote. This is a rational function. Therefore, this would be considered an algebraic function. Because technically to get here, we would have to use a series of addition, subtraction, multiplication, division, where we have one function divided by another to get to this graph here. Looking at graph number 5, once again, taking a look at this, it goes up, down, increases, decreases periodically and predictably over time as we go through the graph. Therefore, this is a trig function. And last but not least, graph number 6. We can tell kind of by looking at it that it has a vertical asymptote here, but only a vertical asymptote. Okay? When there's only a vertical asymptote, and there's nothing else that accompanies it, like we see with number 4, this is technically what we call a logarithmic function. Now, it could be a log base 2, could be a log base 3, could be a log base of anything. Until we know exactly what the points are, this is the pattern that our logarithmic functions kind of follow here. Okay? So the last part here that we want to talk about are our transcendental functions. And they are our exponential, logarithmic, and trigonometric functions. Now, the reason we call these transcendental functions is that we cannot define them using addition, subtraction, multiplication, division, any rational roots, or square roots. All of these are excluded from these 3 here. So once again, exponential is anytime we have a constant times another constant raised to a power like that. Logarithmic is basically the inverse of the exponential. So it would be, for instance, it would be something like this. So it would be b times log base A of x. And then trigonometric is your sine, cosine, tangent, their inverses, as well as your cosecant, your secant, and your cotangent. Okay, so anything that follows that periodic, repetitive, and predictable pattern on the graph, those are all considered trigonometric and can't be expressed using any of our basic algebraic functions.